My name is Charlie Crocker. Right now, I'm at Autodesk, and I'm reporting into our Senior VP of Products. Autodesk is a very, very matrixed organization, so we've got a lot of product teams, and each product team really acts as its own island of development, and then there are different initiatives that help kind of bring and sew the different products together to provide cohesive customer experiences and data flow through the system for our customers. So one of the areas that we have really wanted to accelerate in within the context of our development organization has been data, big data, data access, and having people work consistently. So I used to be on the AutoCAD team, and I was doing a lot of work specifically for the AutoCAD team, but it was really hard in that specific group to try to influence out. So they asked me to work with the Senior VP of Product and actually drive behavior and systems and implementations and consistency across our different product teams. So that's where I'm at right now. Before that, I was actually a product manager on the AutoCAD and the AutoCAD Map 3D teams, really focused a lot on geographic information systems. Before that, I was at a small company that we started, a consultancy, doing really GIS implementations, which I kind of think of as maybe big data round one. We did, a lot of what we do today. The tools were more difficult. We used a lot more relational databases. We tried to use object-oriented databases and other things. And so it's been really great to dive back into this world as the products are just accelerating. And so today I'm going to actually walk you through kind of a story of how we have implemented, gone through the process, how we onboard different teams. We've run a couple proof of concepts where we've identified some performance gaps in the overall pipeline, and it's a work in progress. So I'm really here to share our work in progress. One of the things I love most about this community is that we're all talking to each other. It feels like we're supporting each other. This is not a competitive environment. It's an environment where we're going to help each other out. The thing that blows me away the most right now is some of the best technology has been put into open source. So one of the tools we're using here today is Kafka, and thank you for LinkedIn for putting it into the open source community. We're using Hadoop. Thank you for putting that into the open source community. These are tools that we could have been somebody's competitive advantage, but we're all getting the benefit of both adding to the code and using it. So it's a very exciting time. So Autodesk, what do you associate Autodesk with? Usually there's one product. AutoCAD, right. So we are, in most people's mind, the AutoCAD company. But Autodesk, we're really in several different markets. We're in the media and entertainment market. Our tools are used in most commercials that are you see on TV. They're used in movies like Avatar. We've also are part of most gaming engines. We also have a huge manufacturing base. We have so people who develop planes, who develop cell phones, who develop chairs, anything. They design these things. They're using our software. We're also in the architecture, engineering, and construction space, and that's AutoCAD. But we also have Revit and many other tools. And we use a lot of tools now to start expanding into broader geographic areas. And so what we're starting to see, if this is kind of time on the increasing in this direction, Autodesk has been around for over 30 years. And you saw in the talk this morning that they really saw Postscript and CAD as really two things that change the way people are able to, deliver value and make changes. And so one of the things he talked about, which I thought was interesting, was you finally get the design, it's on your desk, and then your client says, hey, can you move the master bedroom to the bottom story? That's a big deal. So now within the manufacturing arena and within the building environment, we've actually set up, using the cloud, the ability for people to do 100, 1,000 variations, and not just variations on moving the master bedroom to the second floor, but optimizing for sustainability. Maybe you want to try 500 different window types. Maybe you want to try different materials. Maybe you want to reorient the building based on the sun. Maybe you want to change the size or the direction of the airflow in the building. all of these things are now parameters that you can start to tweak to really come up with the best design. And all of that is generating huge, huge amounts of data and also is requiring more and more computation. Another thing, and I'll show you a little bit of this as well, is reality capture. So people, he showed today people drawing with, drawing lines. A lot of our, not a lot, some of our customers are now starting to transition into not even drawing lines. They're just scanning the space, and they're doing the design within the context of the cloud, of the point cloud, of the mesh. Why do I need to actually draw the lines in the room if I can just scan the room? Then I can just draw the lines of the thing that I'm adding into the room. So these paradigms are changing, but those paradigms are driving us to have huge volumes of computation and of data volume. So I'm just going to show two things to kind of give you a little sense of what we're talking about. This is just a fun little video. I'm not sure how well it's shown up there. This is a point cloud that we took of San Francisco. That's our office on the left. And you can see just zooming in through the city. We're talking about billions of points being captured, and the ability to then, within the context of this, do a variety of different things, whether it's redesigning, doing retrofits, or anything like this. So just huge volumes of data, and this is how our customers are starting to think about the environment around them. Another one I'll show you, a lot of our customers, if you ever get to our San Francisco office or our Boston office, we've got a great gallery where our customers show off their, we have exhibits. It's a curated museum of exhibits from our customers. And so we've got a 3D printed Mercedes-Benz, we've got a Lego dinosaur, we've got scale models of the new Oakland Bay Bridge, there's electric guitars and surfboards, things that our customers have 3D printed, designed, or whatever. This happens to be something for emerging markets that allows you to put any type of fuel in it and use it to cook with that fuel. And so I'm going to skip a little bit ahead on this demo because the main thing I want to show is we're inside a simulation tool, and you're able to, within the context of the simulation tool, send data about the structure of that actual product up to the cloud, and then run hundreds and hundreds of simulations to figure out how to optimize either the size of the input, the amount of heat dissipation needs to be on the back here, and then we get huge flow paths. So this is the kind of stuff that our customers are starting to do on a more of a regular basis, and Autodesk has moved from being a desktop DVD shipped to you company to a company that connects those tools to tools that are in the cloud. And so a lot of what I'm going to talk about today are the things that we're doing moving forward to really help optimize and create that experience. And one of the first things we need to do for that experience is that we really need to get control of the information that we have and start turning that into data products for our internal customers and data products for our external customers. We want you, the user of our products, to be able to go in and look at how your usage is, how you model the different information. How do people who built things similar to you, what did they learn, and can you learn from that? There is so much information in this community that can help builders, manufacturers, media and entertainment people work together. Okay, that's my Autodesk spiel. We'll move beyond that now. So I'm going to talk a little bit about our real-time monitoring and analytics platform and kind of how we started to do this. So when I moved under the senior VP, I was asked to really drive a cultural change. We've always been data-driven. We've always focused on information and surveys and going out and talking to our customers. But as we've moved into the cloud, we've had unprecedented access to huge amounts of information, but only a couple people have access to that. And sometimes, he talked about it today, you have to go out and hire a consultant to do it, or a lot of external stuff. So what can we do to make that data easy to access and trusted? And then we're going to be able to be responsive to our customers. We've always done build, measure, learn, but we would build something, we'd put it into the market, we'd learn about it, and then we'd iterate on it. Now we can do this on a daily basis, sometimes even an hourly basis. I mean, this is the new paradigm for all of us in terms of how quick we can respond to our customers. So we're doing this through a couple different approaches. First thing is we're looking at data sets. How can we provide consistent data sets across the organization that are trusted and accessible from the tools that you want to have access to them? We've got to have agreements. Like I said, we're a very matrixed organization. So if the team that's building software X wants to count monthly active users this way, and the team that wants to count over here wants to count monthly active users a different way, and then the CEO wants to just know total monthly active users, we're screwed. So we've got, that's just one tiny, tiny piece of a bigger puzzle that we're trying to that we're really working towards driving. And then there's a lot around innovation. I do not want to stifle innovation in the teams. Each team is going out, they're doing their own pilots, they're actually bringing in different software vendors, and they're trying things. And if we find something that sticks, then I like to take to get involved and to help drive and stoke that fire of success. And then there's a lot around notice and consent. We have data, we have this concept of data that's in our property and data that's outside of our property. So if somebody's on a desktop, that's your desktop. We can't come in there and start looking. You can send us information, but I can't come in. If it's on our servers, then we are going through our servers and we actually can see the information. But we have a promise to you, the customer, of what we will do, transparency, privacy policies, and all this. And we need to be consistent across the company. We can't have each team doing that. And then finally, tools. I want people to innovate, but at the same time, once that innovation has happened, I want to be able to share that innovation and have us start to leverage it. So there's two tools internally that we've had for a long time. Long time in this world is like a year and a half. We've had for a long time, and it's taken a while for them to grow. So, and those are Splunk and Tableau. For the longest time, we had somewhere under 10 in terms of the number of users. And then you get a couple mavens, you get a couple people really interested, and then you start showing some value. And now we're well over 100 for both, and with a much steeper kind of hockey stick trajectory. And so it's very exciting to see. So the data lake. You've heard this term, you've seen it in a lot of places. This is something that we worked really hard on internally, and we had multiple groups. We had marketing teams, we had our EIS group, we had our product groups, and we took this analogy of a watershed and of a data lake as a way for us to communicate to each other. And I'll show you kind of how this works for us internally. It's a cartoon. You may agree or disagree with some of the details. You can push the analogy as far as you want to data puddles and little data streams and all this kind of thing. But I just want to give you the context of kind of how we're talking about it. And in that, you'll start to learn about some of the tools we're using and where they fit into that. So once again, similar to when I was in the GIS, geospatial world, it all starts with the data. The applications around that data, you guys are all familiar, they're changing incredibly rapidly. There are companies that didn't exist a year ago that exist today, and there's companies that exist today that won't be here tomorrow, and that's happening incredibly fast. So, like in my old geospatial days, I didn't want to lock my data up into some proprietary technology. So we have Hadoop at the center of this. We're actually using EMR as our Hadoop. And once the data has been processed, we tend to store it in S3, and we can talk in more detail about that. The key thing for us, and part of my communication to the teams, is about instrumentation, right? So how do we capture, how do we get access to that information? We got a lot of products, but a lot of them are just sending noise. And so we've got tools, we've got things that can instrument desktop products, we have things that instrument mobile products, we have things that instrument web services. And some of those things actually just send data to a service. So for example, for a desktop product, we have that send to a common service, and then that can pump data into our pipeline. We have a variety of ways for collecting that data, but right now the main way and the way that we're trying to standardize on is Kafka, and we can talk a little bit more about that. So up on the left, these are our services and our products and this kind of thing. And down here, we're starting to get into our partner data, our business data, SAP, this kind of thing. And what's interesting is we've had a couple projects going in parallel for about a year. One has really been getting all of the product data together. The other one's been getting all of the system, or all the financials and ops data together and bringing them in. The ops team has got a lot of resources, and they've generated about 5% of the data that the products do, right? I mean, when you look at Salesforce, when you look at SAP, when you look at any of your business objects in those systems, they're really not managing that much data. We are dealing with huge volumes of data when we get up there. So some of the data we're processing. Okay, this is our little processing tool here. Right now, that processing tool is Splunk, and we'll talk a little bit more around that. So we have the data, it's instrumented, it goes through the Kafka pipeline, and it pumps right into Splunk. And I'll show you a architecture diagram at some point. The reason that we're doing this is because people were just dumping log files that were ugly, they didn't even have the data in the log files that they wanted. So we need to have conversations. What questions do you want to be able to ask? What's your app do? And help them to start structuring their log files. So you can pollute the lake if you want, or you can filter and kind of clean it a little bit before the data goes in. And now we have some consistent schemas, meaning like if you're going to have an identity record or you're going to talk about a certain file type or something like that, let's all talk about it the same when we send the data in. It'll make it a lot easier. We can always use text algorithms, and we can do discovery on completely unstructured data, but it's really nice if there's a little structure. It actually helps us to move things faster. And then we have our teams: products, marketing, sales, operations, and all of these teams are beginning to get access to this information. So the information kind of comes in two ways. I put the dive symbol here because we've got some geeks. We've got some, what do you call it? Data scientists, full-on, application developers. A lot of our software developers, instead of using, Tableau or any sort of visual tool, they just want to program against it. They just want to be able to go in and write a Hive query or write a script or write some SQL. And then we've got a bunch of people who don't really know anything about data schemas and structures. And so we're beginning to build out, we're calling a self-service tier. And this self-service tier does include things like Tableau and other products. And we'll show you some of those things. And so the theme here: consistent, trusted, accessible. This is what we're trying to drive in our overall organization. And we're just using this cartoon here as a way to communicate it and a way to talk about it. So I was speaking with my manager the other day, and I was trying to tell him how cool Impala was and why we really thought it was something that we might want to try. And he's just looking at me. He's an MBA and he's not a techie guy, but he gets stuff. So I explained it to him in this way. Right now, we're taking a bunch of our data and we're making copies of it. And we're putting it in Google Big Query and we're putting it in Redshift, which is great. It's a fast access layer. Tableau can get access to it. You can use Redshift and Google native queries to do stuff. That's great. But we're copying our data. So I just said, hey, it's kind of like drilling a little pipe from the self-service architecture without copying the data and going straight into the data lake. Bingo! He understood it. I was able to communicate to an executive, a complex topic, and we were able to have that conversation. Another way to look at it here is, why do we need different types of Hadoop? What are the clusters? How are we doing this? We're going to have 3 different types of clusters. We have our data ingestion cluster, and this is really something that we keep up all the time. We're constantly running. So these are going to be instances that we purchase and that we keep. Whereas we have transient clusters depending on the different analyses people want to run. And if the guys in the dive suits want to do something crazy, well, then we'll spin them up a cluster. And then we're going to have data that's stored in places where we can have ad hoc exploration, right? And each one of those needs a different SLA. They may not need to be fully managed all the time, this kind of thing. So this data lake really helped us have that conversation internally. And our goal, fundamentally, and I've challenged my team, is to be able to support the big number at the top, right? A lot of us in the data geek land were really good at supporting the groups down here. When I was in the GIS world with ESRI and Intergraph and all that, we were really, really good at supporting these guys. And the guys up there had to buy pizza and slip it under the door, and you had to wait 2 weeks to get your results back, this kind of thing. So how do we move up this stack here and really get the non-technical business users to be able to get value out of this? And this is a work in progress. We need to find the tools that are going to really unlock that. And we found a couple, but they're not ubiquitous yet. So now I'm going to go, we've talked a little bit about Autodesk, a little bit about our kind of data lake and how we're starting to grow those pieces. I'm going to get a little more technical. This is not going to be a super technical talk, and if you want to, we can talk afterwards, or we can even hook you up with some of our even more people more technical than I am. So this is our data pipeline, and this is kind of how we describe it. So on the left, once again, are the services that we've instrumented. This is once again for our products. This is not where our Salesforce data is coming in. This is not where our SAP data is coming in right now. We can talk about that. So what we have is this data gathering phase here. So all data, analytics data, debug data, system data, it comes screaming through Kafka. And Kafka is great. We can tune it. We can shut a certain source off. We can open it up. We can say, let's sample it. It actually has a great storage mechanism. So what we do is instead of sending debug data into Splunk, we just have it go into Kafka. If all of a sudden there's an error, somebody wants to go look at the debug data, they say what the time frame is, that data gets dumped into Splunk, now they can do their queries, right? Makes it really easy for us to, debug data we don't keep. You don't need to keep after a week. This is stuff that's just, are things happening? I'm monitoring my system, and that's what we use that for. And then in Splunk, we keep about a month's worth of data, about 30 days worth of data. So we keep a little bit longer if the data is not fully managed yet. But Splunk we use to do basic analysis, to do some aggregation, and we do real-time view. When we started, there was about 10 people maybe that were using it. We've got a much, much bigger volume of people now using Splunk. And so we're now seeing that as an asset. I never would have thought that a tool with a scripting language would be something that people up the pyramid would want to use. But we've got 300 interested parties now in the company outside of dev. They're figuring out that I can write simple Splunk queries. I can actually, it's an easy little language for me to use. And so that's becoming something that's more and more valuable to the company. And then we move stuff from Splunk. So we actually use the Splunk to Hadoop connector, and we take the aggregations, we use some Hive, and we actually kind of flatten out a few of the pieces of information, and then we pump it into Hadoop, and it ultimately gets stored in S3. From that, we then work with teams and build out data cubes or aggregations or curated views or whatever you want to call them, and we put those into a couple different sources. We're supporting, we have data in S3, we have data in Redshift, and we have data in Google Big Query. And they're kind of solving just different things, different teams. I have a feeling we'll consolidate at some point, And then we have tools like Tableau and Click and other things that we use to then access that data. So this is kind of really giving you the, showing you what's up. Core services, these are services that we have that other services use, like login identity, storage, these kind of things. So we may have an architectural service and a manufacturing service. They both need the same login identity system, so we have one identity system. Or they may need one file storage system, so we have one file storage system, etc. So those are what we call core services. Then we have 360 products. You can go up and see we have BIM 360, we have InfoWorks 360, we have AutoCAD 360. These are tools now that are on mobile, they're on web, that our customers are using. Then we have a lot of our desktop products. We have somewhere around 120 to 130 desktop products in the market, and then operations data. We have 1.3 billion transactions hitting our system every day. 75 topics in Splunk. There's actually more than this because people throw stuff in kind of experimentally, but these are the ones that are really core that we're using. We're indexing around 200 to 500 gigabytes daily. The cool thing about Splunk is you index on read, right? So you take unstructured data and you are able to look at it like it's an indexed data set. If you don't like the way it indexed, yeah? I joined the group after they'd already made some headway with Splunk, and so we now have, this is one of those things where, once there are groups in our company who are like, let's save some money, let's cut this out, and we're like, well, the opportunity cost now of having 300 people that already know how to use it is not worth the change. Yes, there were a lot of things that we did look at a lot of other potential places. We looked at different things than Google Big Query. And we are very open to, at some point, swapping that out, right? We really want this to be a modular pipeline, and if another group wants to manage it and they can meet our SLAs, and it can do the things that we want it to do, then we will support that. But as things get more use, it's harder to extract those from, and I don't want to take that from their hands because they're actually being successful. We've got about 800 terabytes and growing in our Hadoop system right now. We've got about 300 S3 aggregations. These are, the kind of the processed Hive queries that we're keeping. They may be a daily, a weekly, a monthly aggregation. There's the raw data sets. And then we've got 100 Tableau, 50 Tableau desktop. We're using Gecko board. We really like Gecko board. We've got 150 ClickView users. We're currently an enterprise ClickView site. We were before we discovered Tableau. We're seeing Tableau start to grow a lot more. So, so things change over time. And then we're using Google Big Query. We've got a bunch of tables in Google Big Query, and those are serviced to the rest of the organization. So here's just an example. One of our core services, I'm not going to identify them in all this, but what you're seeing is a core service. You're seeing 60 million hits a day coming in. This is just a quick little view in Tableau. And each one of these colors are different services that are using that service, right? So we really are this is one of the services that we're dealing with. So we're dealing with pretty large volumes of data that are coming in pretty quickly, and we're figuring out now how to respond faster and faster to the data sets. Here's another one we just launched. I love seeing this because we went literally from before March of 0, and we're now up to 700,000 users a week, and they're distributed all across the world, right? So to me, these are the kind of things that are really exciting to be able to very quickly work with. And so this is all stuff that we're able to do super, super quickly in Tableau, connecting to data sets that are coming out of that pipeline. Yeah?
So what's the latency between the data when it's generated and when you can actually look at it?
So I'll go back to here. So Splunk, I can look in the last 5 minutes and see what's happening, right? In Hadoop, we're dumping the data from Splunk to Hadoop once an hour, and then the aggregations that go into Google BigQuery vary. Sometimes we update them by the hour. Most things, even if it's a monthly, we update at least once a day.
And does all your data go through Splunk, or does some of it go straight from Kafka?
Right now, all of the product data that we're onboarding, and I'll show you the onboarding process, we actually put through Splunk. And a lot of the teams really like that because once you get out here, you're getting a fairly structured data source. In Splunk, you can see everything, right? And as you start to really understand the naked data, it's really, certain people really have a, wait, just a sec, go ahead.
So why not connect Tableau directly to Splunk and not have that?
Let's talk about that, and we'll show you the proof of concept that we did. So.
What is the query performance on those visualizations that you just showed? Like how long do those take?
Oh, on this one, this was probably a minute and a half, something like that. It does take a little bit of time, but yeah. And so those are some of the gaps we can talk about. Like, we're putting stuff in Google BigQuery. The more I talk with all these different companies, I'm looking at my crystal ball, and 2 years from now, we will not need a fast access layer. With Spark, with a lot of the new kind of we're going to be able to just save the queries and have some sort of better caching mechanism, things like that, as opposed to, we're all rebuilding databases. We're like taking all this unstructured data from Hadoop and we're structuring it and putting it into SQL Server again, and we're putting it into Oracle again, and we're putting it into Google BigQuery again. What are we doing? Is it just because that's what we remember how to do, or are there new ways of doing it? And so it's really, I think we're at a cusp right now where the technology is going to allow us to store all of the questions and the schemas and the structure, but not necessarily the data. And I hope we get there. I hope we get there in my lifetime. So a managed source, I said consistent, trusted, accessible. This is just a list of things that we think about. I like publishing data. I don't care if it's good, bad, or ugly. You just need to know, is it good, bad, or ugly when you're working with it, right? And so we just have a list of things that we think about before we say, this is a managed service. So some things as simple as a clear service owner. Has the data been validated against more than one source? Has legal signed off on the fact that we even are using this data for the said for whatever you're using it for? There's a couple things that are technical for us on this. And then a key thing here for us is, have you created your metadata and are you maintaining that? Do we know where the source is, how often it's updated, who we can contact if there's an issue, and are we automating notifications around whether or not the service is down, right? And as we move more forward, we're starting to predict when we think the services will be down, right? So those are the kind of things we're going to be able to do. So what I'm going to do now, go ahead.
For your metadata, do you have a data registry across all those stages of the pipeline, or how does that work?
I'll show you a little bit of what it is a little bit later, and then we can talk about it. I have a couple screenshots from the actual interface, and so we can take. It's a pretty much of a poor man's version right now. We're looking for a vendor that can supply that, and we may just have to. Anybody want to start a company? Okay, so now what I want to talk about is how we onboard the teams, because we are a matrixed organization. So I have this team, and boy, are they really confident that they're going to be able to do it their way. If they do it their way, then it'll get done fast. Nobody will bother them, but they lose some of the value. I have a team of engineers who can build out aggregations, who can build out data sets, who can build out dashboards. Our CEO wants to have consistent reporting across data sets. We'd actually like to know if our customers are using more than one application, right? Those are things you can't do when you work in silos. And so I've had to do a lot of marketing to our teams to sort of show that value. So we have the carrot and we have the stick. So here, I'll show you kind of the way we think about it. So we literally have steps that we go through the process. So first we have to engage with the team. We always make sure we engage with a business owner and with a developer, because the business owner may be excited, but if they don't have development support, they're not going to get anything done. And you can talk to the developer and geek out forever, but it'll never get prioritized on their list if you're not talking to the business owner as well. Then we forward the data to Kafka, and we don't care if it's ugly as sin. Go ahead, just send your data. We have a couple different .NET and a Java forwarder that you can just deploy. We have a wiki that describes how to do it. It's very quick. Start pouring your data in there. Once it goes into Kafka, we create a topic in Splunk, and now they can start looking at their data. There's nothing like looking at your data and seeing how ugly and unusable it is to get them motivated to start fixing that data. So then we have a conversation about, hey, we have some facets and we have some recommendations on your schema, how you should organize that information. And so now we start to apply the log schema. So there's only like about 20 things that we would say, hey, let's make sure we use the same time zone. Let's make sure that we, those kind of things, right? If you're going to use geographic callouts, let's call them using the same, data sets and that kind of thing. Once we've done that, then we validate the log schema, and we can start forwarding that data into Hadoop. And so we do what we call our PL0, which is just an hourly dump that just takes it in sort of a flat format. We're actually moving forward now with a more nested format. We started with flat, now we're moving to a more nested format. And we have our development team that does this. So we have a group in Singapore running on 2-week sprints, and we just keep this stuff in their backlog. Then we work with the product teams to define the aggregations, the curated views. So now that we have this data in Hadoop, what do you want to do with it? You want to mash it up with some of these other data sets we have? How do we want to deliver that information? And then once we know enough about that, we can deploy some of the data cubes. We do this usually with Hive, and then we pump that data into Google Big Query and S3, which gives us a couple different ways to access it, and then we can decide how we want to publish that information. Is your team a ClickView team? Well, then let's use the REST API. Is your team a Tableau team? All right, we're going to use Google Big Query. Are you all 3, 4, 5 different things? I don't want to get in the way of your technology. I just want to make sure you're using the right data and you trust that data set. And then we have our ops group working across that. But what I defined actually has a couple pretty big bottlenecks, right? And those bottlenecks always come around the sprint. If we have to wait 2 weeks for the team in Singapore to do something, it stops, like they said this morning, it stops your flow, right? God, I want to answer that question. Now I'm stumbling. I'm not going to be able to do. I'm not going to be able to do that. So we're trying to find ways where we don't have to go to the Singapore team to create and deploy aggregations, or and so we've started to run a couple different proof of concepts. We have not made any final decisions here. What I show you is not an endorsement of any specific technology or team. It's just stuff that we've been playing with, and I'm going to give you some of the information. But we're just that's where we're at. So we've been running a couple different proof of concepts, and this is answering the gentleman in the middle's question. Why don't we use Splunk, or why don't we use Tableau, for example, and go directly into Splunk, or why don't we use Tableau and go directly into Hadoop? Or why don't we use Splunk and go directly into Hadoop? So is there a way that we can allow non-technical users to explore, create, and publish aggregations from that data lake and visualize the results in the tools of their choice, right? So right now, to do that, I have to insert a development team. And based on the technology that we've seen and the technology that's evolving, I don't think we have to do that. I think there are certain areas where we want to do that. But I think that we can open up this whole pipeline to a lot more people. We can democratize the access to Hadoop. You don't have to program Python. You don't have to program Hive. You don't need to know SQL. And there's a lot of cool companies that are providing you, WYSIWYG or drag and drop. And so we're starting to discover that there's a real opportunity in that space. So I'm going to talk a little bit. How are we doing on time? We're doing great. I'm going to talk a little bit now about some of the proof of concepts that we've done and where they fit, really with a goal, a focus for us on the question that I just showed you of being able to access that data, really allowing more people with less technical background to access the data. So like I said, I'm not sponsoring or anything here. These are some of the apps. Some of these we've run some POCs with. Some of these we're looking at. There's a bunch of other ones. I could put a long list. We could all go down to the floor and meet 10 other people who might, fit into this or say they fit into this. We've all heard the story. What I wanted to be able to do with this is explore and create aggregations from our data lake, which is Hadoop. And can we do it directly from Splunk or Tableau, right? And the reason I picked Splunk or Tableau is those are tools we already are comfortable with, right? We've got a team of people who like Splunk, and we have a team of people like Tableau. If you have to come in and tell me I need to remove those, it's just a bigger activation energy to get that happening. Can I remove or reduce the need to store copies of aggregations? At this point, the answer still feels like it's no, but we're getting there. And it depends on how fast you need to have access, right? Yeah? We're using EMR. Yeah. But we're also building out an internal system to be able to have for data products. So being able to deliver faster response that we can really tightly manage to deliver value to customers, where they actually get to consume stuff from the data. And then can we create aggregations with little or no development from our dev team, right? Those are simple use cases. I come from a product management background, so I'm applying sort of product management to the overall pipeline. And my customer right now is internal, and I think within the next 6 months, my customer will start to become external. And that's the part I'm actually really excited about. So the two that I'm going to talk about are just Hunka and Impala. These, like I said, these aren't sponsored. This is barely scientific. We're just starting on these, and we're learning. But I think it'll give you a context for some of the questions that we're asking and some of the answers that we're getting. So for Hunk, we already have in Splunk 100 users. They know the Splunk query language, and we're using it for real time. So the only question for us is, can we use it also to access historical data, right? So Hunk is equal to Splunk plus Hadoop, right? Clever. Everything in this industry is clever. The shirts, everything. So Hunk it's really just Splunk. It's just the Splunk environment, but it has tools to allow you to connect to and create virtual indexes inside of Hunk. So we really just wanted to say, well, gosh, our team knows how to look at real-time data. Could they use the same tool to look at some of the historical data? If so, I don't have to call the developers every time they need to do it, or they don't have to get somebody on their team who knows Python, right? That's the kind of thing that we were trying to solve. So we did it with a small data set. We liked the results, so we're going to try it with a bigger data set. We put the data both into HDFS and we put the data into Amazon S3. We aggregated the data, and then we used different functions within the tools to try to accelerate that to get even more out of it. And this is not an optimized instance. There's a lot of things that we could do to improve this, but it just kind of gives you an idea. So these are the execution times of the queries in S3 and the execution times of the queries in HDFS. So putting the data in HDFS was definitely faster because you don't have to mount the data from S3. So that's great. But they're still pretty slow, right? That's workable if you're, it knocks you out of your flow, but those are actually okay numbers if it means the difference between that and 2 weeks of development, right? So, I'm comfortable even if I have to go for a half hour and get a cup of coffee, if I don't have to get into the queue, create the user story, get myself into Jira, prioritize, and then get it built. I'm really glad we do that because we need it for certain things, but I don't need it if I'm just doing some of my own analysis. But if we added the acceleration from Hunk, we were able to get it down to a much, much more reasonable number. And then we ran the same two visualizations in Tableau using the Splunk connector the gentleman referred to from Tableau, and we're able to get fine results, on this. So this was interesting enough for us to say, hey, maybe we should do a little bit more and see if we can actually, instead of having this one little instance over here with some data, let's do a pilot where we actually can connect to our raw S3 data and see if we can break it. Yeah?
So you were using Tableau to go through Splunk to go to
What we're trying to see, the cool thing with the new Splunk connector in Tableau is I can actually create aggregations in Splunk, right? Really just saved queries in Splunk, and people can access those in Tableau, right? So we've already kind of tested that pipeline, and we're happy that that relationship is working, and it's a way that we can deliver more ad hoc value, or teams can now publish data more quickly. By doing this, we actually killed two birds with one stone, right? How can we, so we're coming at this Tableau, Splunk, Hadoop, and then the next one here is Impala, which is really Tableau straight to Hadoop through the the Impala Tableau connector, right? So it's fun because we've got teams that are doing this heavy lifting. I'm getting to go out and experiment. I feel like I've got my lab, and we've got a bunch of different things we can do, and we're trying to figure out things that work well for us. And if we find something that works, we'll tell you. And if you find something, tell me. So another one we did, this was actually a little less formal, but a lot more data. We had these two different services, around 300 million and 66 million records. We did the analysis on the raw log data. So this was not the process data. This is actually going against the raw log data. And we were able to run most queries that we wanted to do in under 2 minutes. Similar queries with Hive were taking 5 to 10 times longer. And so we're in a much better position with that. And then we connected to the data through the Cloudera. And this was really just an initial test. We've got a couple new partitioning schemes that we're going to use with the data that we think are going to help change a lot of the things that we're doing and improve performance. And then we could also just up the cluster if we wanted to get a little more performance. Yeah? Is it the what? Oh, I think it was the Parquet format. I didn't do this experiment, and I read through the results this morning. If you talk to me afterwards, I can bring up the email, and he mentions that. I don't know. So that was that. He asked for the whether we use the Parquet format on this. So those are the two that we did. They're promising. This is what's giving me hope that in the future we won't necessarily have to use an unstructured database to build a structured database, right? And I've seen a lot of people do this. I've seen it at our own office. I've seen it at other companies I've talked to. People are spending a lot of time taking data out of a structured database like SAP, moving it into Hadoop, where it's really kind of unstructured, and then putting it into Redshift, which is structured. So they're kind of doing the same thing. The only difference may be that they're getting a little blending happening in Hadoop that on data sets that don't exist in SAP. But I think there's a lot of the old paradigm that we're all still thinking ETL, we're all still thinking tables and schemas, and so I still do. It's what I was born and bred on. So it's a new time. All right, data access in Tableau. So this is kind of the final foray here. So once again, the philosophy here: one source and multiple access points, right? So one data lake, and then I don't care what tool you use. Use the tool you want to use. So for us, we're doing daily pushes using Hive queries into S3, and then we're using a REST API against S3, and then we're dumping the same data set, structured exactly the same, into either Google BigQuery or Redshift. And that tends to be more based on teams now, not technology. And so I think at some point, like I said, we'll merge on that. If you want to use Tableau Server right now, you access the data, Tableau Server or Tableau, you access the data in Google BigQuery. And I'll show a little bit more about what we're doing with Tableau Server in a sec. If you're using ClickView, they access REST API is great. So we just connect directly to the REST API. If you're using Gecko Board, I had an intern this summer build a little Python library that allows us to access the data directly from S3. 3 different access points, 1 data set. And then if you want to access the raw data, you can do it through Tableau Server, you can do it through REST APIs, or you can do it through Hunk and Splunk topics if you just want to get access to the data itself. So publishing to Tableau Server, the cool thing for us in Tableau Server, we've named a bunch of our tables, we've named a bunch of our, in a sense, curated views. If I change the data source behind from Google BigQuery to Tableau to Splunk, as long as my schema is the same and my name's the same, it's not going to matter. And so what we've done is we've abstracted the permissioning. So right now, I'm the only one who has access to Google BigQuery, but I have a bunch of people through Tableau that have access to certain tables and pieces of Google BigQuery. So it allows us to treat that really as a separate entity. And if I decide in the future that Google BigQuery isn't what I want to use, I can swap it out seamlessly without my users, my customers seeing that. And that's all using the Tableau Server interface. So it gives us that user control. We can set security by project or security by site. And like I said, it's data source independent. And what we're using Tableau Server for is to just provide daily aggregations. So there's a nice list of aggregations. We have some general data set workbooks. They're really self-starting workbooks. Hey, here's a data set, you want to learn about the data set, why not use this workbook, this dashboard to do that? And then one of my colleagues is here. He's built a system to do automated PDF generation. So he's got a sales team. They don't want Tableau. They don't even want a clickable dashboard. Let's just give them the report as a PDF, and he's sending it out to hundreds of people. And each one is a different report based on the person, the region, this kind of thing. And he's been able to do that using Tableau. It's been great. So you asked what our system looks like. So to me, this is rudimentary, but this is the beginning of what I really want to have happen. And it's really a searchable wiki. So this is how our customers get access to it. You can see here the little green check mark. Those are managed data sets. There's no green check mark next to this one right now because it's a good data set, and I'll tell you why, but it's not a perfect data set yet, right? There are things that we can do to improve it. You as a user, do you want to get access to that data in Excel? Do you want to get access to that data from Tableau Server? Do you want to get access to the ClickView dashboard? This kind of thing. And then can you search through this? And so we've got many data sets now that are coming online here. And I don't consider a data set online, even if you have the data in Google BigQuery and you can access it, until you've written the page that describes this. And I'm not going to go into more detail. This is probably already more than I should show you. But if you click on identity, it goes down. Who is the owner? What's the schema? What are the sources? What are some of the other information? or even for a developer, if that developer wants to use this service, how do they instrument and get involved into that service? So then you come over here and you click on the thing that says Tableau Server, click, and it takes you to a sub-page. Tells you, I've blocked out most of the information that would matter, where the servers are, how you log into the servers. We currently don't have an enterprise license, so I have a couple extra in my pocket I can lend you for a little while. If not, you may need to purchase your own license. Here are the different data sets that we have access to, and if you click on this, it'll take you to a page that gives you more detail about each of those data sets. We have this naming conventions, which are kind of annoying, and we'll probably clean them up over time, but PL2 is daily. PL3 is monthly. PL4 is weekly, right? So these are some of the systems that we're starting to put in place to help drive that. And those record counts are old. I did them once. I'm not sure it really makes sense. But this is really kind of manually done, and we'd love to see a tool that allows us to do that. And I know there's lots of tools out there that kind of do that, and a lot of the tools that, especially the ones that are end-to-end, who say they can do everything from ingest to share, have interfaces that allow for some of this, but it really only works if you're on their pipeline, right? And so it'd be nice to abstract that a little bit and get off that pipeline. Maybe we can start an open source project. It seems like this would be a good thing. Yeah?
We've just done some of that in Tableau Server and embedded it in Confluence, looks like you're using.
Yes.
So we've just done some of the self-documentation in Confluence with Tableau Server embedded iframed in.
Cool. Give me your card. So what's next? So I'm really getting to the end here. So I just wanted to end with this picture because we definitely spent a lot of time thinking about this. This really helps us have a conversation about tools, about resources, which group in our company should own the data lake, which group is owning this. Should it be each individual team? Should it be a central organization? This kind of thing. And so this has really helped us to drive forward and have a good conversation on that. So of course we're hiring data geeks, analysts, Python developers. Ping me, please. We've got a lot of fun stuff going on, and we're just at the beginning. And then tap on this, say I did a great job so I can come back next year. And that's Autodesk. So thank you.